Ever feel like you're just drowning in data? Like you're constantly bombarded with information? What if there was a way to cut through all that noise and extract only the essential nuggets of knowledge? Well, that's what we do here on the Deep Dive. Today, we're taking a trip back in time, exploring a tool that predates calculators and computers, a tool that can unlock like a whole new level of mental agility, and really just like a deeper mathematical understanding, the Cranmer Abacus.
It's fascinating, really, how this ancient tool, just with beads and rods, can make even, complex calculations surprisingly intuitive.
Absolutely. Be guided by the Abacus Made easy, which, does exactly what it says, breaks down this incredible tool in a way that's clear and, dare I say, even fun. So whether you're, a math enthusiast or just curious about this ancient calculating marvel, get ready for some serious aha moments. And a huge thanks to London Heartbeat's Z Academy UK for their support in making this deep dive possible. They've got over 150 amazing courses, so be sure to check them out: Facebook, Instagram, Spotify, and YouTube. Don't miss out on those free updates and future discussions. Now, back to the abacus. I gotta admit, I'm a little intimidated by it. All those beads and rods, it seems pretty complex.
It might seem that way at first, but trust me, the beauty of the abacus really lies in its simplicity. Just imagine like a rectangular frame, like a picture frame,
Hmm.
with 13 vertical rods running through it.
Okay, 13 rods, got it. So what's happening on these rods?
Each rod is home to 5 beads, little counters that slide up and down. And there's a horizontal bar called the separation bar. It runs across all the rods, dividing them into 2 sections. So you have 4 beads below the bar and a single bead above it on each rod.
Interesting. So is this separation bar the key to understanding like how the abacus actually works?
Absolutely. It all comes down to place value, the foundation of our number system. Think of each rod as representing a different place value: units, tens, hundreds, and so on.
So like the beads on the far right rod would be our units,
Yeah.
the next rod over would be tens, and so on.
Exactly. And the position of the beads relative to that separation bar, that's what gives them their value. It's like a visual representation of how numbers are built.
Oh, okay. I'm starting to see the logic here.
Yeah,
But how do we tell the rods apart? Is there like some kind of marking system?
you're right to ask that. Under each rod, you'll find raised dots, almost like Braille. And to make things even easier, there are raised vertical lines every third dot. Think of those lines as like commas or decimal points, helping you quickly locate specific rods and separate, larger numbers visually.
Ah, so those are the unit marks I saw mentioned in the book.
Right.
It's like having like guideposts along the abacus, right?
Yeah.
To help you navigate.
Exactly. Now, let's talk about the starting point, the 0 position. When all the beads are pushed away from the separation bar, the abacus represents 0. It's like a clean slate, ready for calculation.
It's like hitting reset on the abacus, clearing the canvas before we start, like painting with numbers. Okay, so we've got our frame, our rods, our beads, and our markings. We've covered the basic anatomy, right? But how do we actually use it? How do we express numbers on it?
That's where the fun begins. So instead of writing numbers on the abacus, we set them by moving the beads. And this is where the magic of place value really shines. Each bead below the separation bar has a value of 1, while the single bead above the bar represents 5.
Okay, so by moving those beads, we're essentially like assigning values to them based on their position. This is cool. Can we walk through an example of setting a specific number?
Absolutely. Let's start with the number 1. To set 1, you simply slide that topmost bead from the group of 4 below the separation bar upwards towards the bar itself.
So we're bringing that bead closer to the separation bar to give it a
Yeah.
value of 1.
Exactly. To set the number 2, you slide 2 beads upwards. For 3, 3 beads. And for 4, all 4 beads below the bar are moved up.
That makes sense. It's almost like building a staircase with the beads, each step representing a higher value.
That's a great way to visualize it. Now let's think about the number 5. We've used up all the beads below the separation bar, right? So how do we represent 5?
That is a bit of a puzzle. Do we move to the next rod over?
Not yet. This is where that lone bead above the separation bar comes into play. To set 5, you clear all the beads below the bar. Instead, you move that single bead above the bar downwards to meet the separation bar.
Ah, so that one bead above the bar packs a punch. It's like a shortcut for representing 5, so we don't have to use all 4 beads below.
Exactly. It's a brilliant design that allows for efficient representation of numbers. To set 6, we'd use that top bead and 1 from below the bar. For 7, the top bead and 2 from below, and so on.
I'm seeing the pattern here. It's a combination of those single beads worth 5 and the beads below the bar worth 1. It's like a puzzle, figuring out the most efficient way to represent each number.
It is a bit like a puzzle. And the more you practice, the more intuitive it becomes. You start to, visualize the
Yeah.
numbers in terms of these bead combinations.
This is so cool. It's like a tactile way of learning math. Feeling those beads move under your fingers as you build the numbers. I can see how this would be great for visual learners and anyone who wants to develop a deeper understanding of place value.
Absolutely. In fact, the book suggests practicing setting numbers that you encounter in everyday life, like the number of chairs in a room, or even your phone number.
I love that. Connecting this ancient tool to modern life, making it relevant. Okay, so we've covered the basic anatomy of the abacus and how to set numbers. I'm ready to take this to the next level. Are you ready to dive into some calculations?
Absolutely. Let's begin with the building block of arithmetic addition.
Bring on the addition. I'm eager to see how this abacus handles adding numbers together.
Welcome back to our exploration of the abacus.
It's amazing how this ancient tool, it's been around for centuries, still feels so relevant and engaging.
It really is a testament to, its elegant design and the power of hands-on learning. So last time, we got acquainted with the abacus, understanding its structure and how to represent numbers, using those beads and rods.
All right, we learned how to set numbers on the abacus, which was a lot more intuitive than I initially thought it would be. But now I'm curious about how we actually perform calculations. Let's start with addition. How does the abacus make adding numbers easier?
Well, addition on the abacus is all about visualizing those quantities and, combining them in a very concrete way. The book begins with the simplest form of addition, adding the number 1 consecutively. So imagine your right index finger is resting on the units column. That's the far right rod on the abacus.
Okay, got my finger poised and ready for action. What's next?
To add 1, you simply push the topmost bead, the one below the separation bar, upwards towards the bar. To add another one, you push the next bead up, and so on. You're essentially building the number by pushing beads towards that separation bar.
So it's each bead represents a single unit.
Yeah.
And we're accumulating them to represent the sum.
Precisely. It's a very visual way of seeing how addition works. But here's where things get a little interesting. What happens when you reach 4 and need to add 1 more? You've run out of beads below the bar on that rod.
Yeah, you're right. We can't just move to the next rod over because that would be adding 10, not 1. So how do we solve this?
Well, this is where that single bead above the separation bar comes to the rescue, the one representing 5. Instead of adding 1 directly, we use our left index finger. The book calls it the helping finger, to push down that 5 bead.
So we're essentially adding 5 instead of 1, but that throws off our calculation, doesn't it?
It does, momentarily, but that's where the beauty of the abacus comes in. Think of it like this. You need 1 penny, but someone gives you a nickel. You have 4 cents too much. What would you do?
I'd give back 4 pennies.
Exactly. And that's what we do on the abacus. Since we added 5 when we only needed 1, we clear the 4 beads below the separation bar. We're essentially returning those extra 4 cents, leaving us with the correct sum of 5.
That's so clever. We're compensating for not having enough beads in the units column by using the 5 bead and then adjusting. It's like a little dance of the beads.
The book calls this indirect addition. It might seem a bit roundabout at first, but with practice, it becomes second nature. You develop a feel for when to use that 5 bead and how to adjust.
I can see how that would become intuitive, yeah.
Yeah.
So we can keep adding 1 until we reach 9, but then we hit another roadblock. We're out of beads again. And this time we can't use the 5 bead because that would take us way over 10. So what happens then?
You're absolutely right. This is where the helping finger truly shines. Our left index finger, which has been patiently waiting in the tens column, now comes into action. To add 1 to 9, we use that left index finger to push up 1 bead in the tens column, representing 10.
Because each bead in the tens column is worth 10. But now we've added 10 when we only needed to add 1. We've overshot our target again.
We have, but remember our money analogy. We needed 1 cent but added a dime. We're left with
9 cents too much. So we clear all 9 beads in the units column.
You got it. We're essentially setting 10 and then taking away the extra 9, beautifully illustrating that 9 plus 1 equals 10 on the abacus.
This is so much more visual and engaging than, just memorizing addition facts. I'm starting to see why the abacus has been such a valuable teaching tool for so long.
It really brings those, abstract concepts to life. The book highlights different ways to think about this process, using money, thinking about partners of 10, or even visualizing subtraction. The key is to find what resonates with you and helps solidify the concept.
Okay, so we've successfully added 1 all the way up to 10. Now what? Do we just keep going in the tens column, adding 1 bead at a time?
That's exactly right. The process repeats itself. We add one at a time in the tens column, using the 5 bead and the helping finger as needed. And once we reach 19, we move to the hundreds column and start again.
Wow, so the abacus handles carrying over effortlessly. There's no need to mentally keep track of those extra tens or hundreds, because it's all visually represented right there on the abacus.
Exactly. And this visual representation is what makes the abacus so powerful. Especially when working with larger numbers, it takes that mental strain out of carrying over, allowing you to really focus on the addition itself.
This is making me rethink how I approach addition altogether.
Yeah.
It's not just about memorizing facts, but understanding the relationships between numbers and how they build upon each other.
That's a fantastic insight. The abacus doesn't just give you the answer, it helps you understand the process, the why behind the what.
This is all starting to click for me, and I bet our listeners are feeling those aha moments too.
Hmm.
But before we move on to other operations, can we delve a bit deeper into adding multi-digit numbers on the abacus? I'm curious how that works.
Absolutely. Let's say we want to add 27 and 36. We start by setting the first number, 27, on the abacus. The 2 goes in the tens column, and the 7 goes in the units column.
Okay, so we have our first number all set up. Now, how do we add 36 to it?
We add the digits of 36, one at a time, starting with the tens digit. So we add 3 to the tens column, which already has a 2, giving us 5 in the tens column.
So far, so good. What about the units digit?
We add 6 to the units column, which currently has a 7. This is where our indirect addition skills come in handy. We can think of this as 7 plus 6, or we can break it down into smaller steps.
Let's break it down. We can't add 6 directly to the 7 because we only have 3 beads left below the bar in the units column.
Right. So we use our helping finger to bring down the 5 bead in the units column, giving us a total of 12, but we only needed to add 6, so...
We clear 4 beads from the units column, and since we brought down the 5 bead, that leaves us with 3 in the units column.
Perfect. Now look at the abacus. We have 5 in the tens column and 3 in the units column. Our answer, 63.
Wow, that was so much smoother than I thought it would be. The abacus made carrying over so easy, and I didn't even have to keep track of anything in my head.
It's all right there in front of you, visually represented by those beads. And the more you practice, the faster and more intuitive the process becomes.
I'm starting to see that. It's like learning a new language, but this language is made of beads and rods. It's fascinating.
And just like learning any new language, fluency comes with practice. The book encourages readers to practice adding a variety of multi-digit numbers, gradually increasing the complexity. This helps build confidence and mastery.
This has been such an eye-opening exploration of addition on the abacus. I'm eager to see how it handles other operations. But unfortunately, we've reached the end of this segment. But fear not, dear listeners, we'll pick up our abacus adventure in the next part of our deep dive, where we'll tackle the intriguing world of subtraction. Welcome back to the deep dive. I'm still buzzing from our abacus addition adventure.
It is remarkable how this ancient tool can make even something, as basic as addition, feel so fresh and engaging. The way it visually represents numbers and their relationships is truly insightful.
Absolutely. It's not just about getting the answer. It's about understanding the process, right? The why behind the what. So last time, we left off with addition, mastering the art of combining numbers using those clever beads and rods. But now I'm curious about its inverse, subtraction. Can the abacus make subtracting numbers just as intuitive?
It absolutely can. Subtraction on the abacus is like the mirror image of addition. Instead of adding beads to represent increasing quantities, we take them away to show decreasing values.
Okay, so it's the opposite action.
Yeah.
But still using the same principles, place value and bead manipulation. Can we walk through an example to see how it works?
Of course. Let's start with a simple one. Imagine you have the number 5 set on the abacus, represented by that single bead above the separation bar in the units column. Now, to subtract 1, you simply move that bead back up, away from the separation bar.
So we're essentially like reversing the action of addition. Instead of bringing beads down towards the separation bar, we're moving them back up to decrease the value.
Exactly. And just like with addition, we work from left to right, dealing with each place value column in turn. So if we had, say, the number 25 set on the abacus and wanted to subtract 13, we'd start with the tens column.
Okay, so we would remove 1 bead from the tens column, leaving us with 1 bead in the tens column and 5 beads in the units column.
Precisely. Then we move to the units column and remove 3 beads, leaving us with a final value of 12, represented on the abacus.
That seems straightforward enough, but I'm guessing things get a bit more complicated when we need to borrow from the next column, just like we did with carrying over in addition.
You're spot on. Let's say we have 42 set on the abacus, and we want to subtract 29.
Okay, so I've got 4 beads up in the tens column and 2 beads up in the units column representing 42.
Perfect. Now we need to subtract 29. Starting with the tens column, we remove 2 beads from the tens column, leaving us with 2 beads there.
Okay, 2 beads left of the tens column. Now comes the tricky part, right? Subtracting 9 from 2 in the units column. We don't have enough beads in the units column to do that directly.
This is where our trusty helping finger comes back into play. But this time, it's a borrowing finger. Since we can't subtract 9 from 2 directly, we need to borrow a 10 from the tens column. Remember, each bead in the tens column represents 10.
Right, so we move 1 bead down from the tens column, leaving 1 bead there. But how do we represent that borrowed 10 in the units column?
We essentially add 10 to the units column. Remember that single bead above the separation bar in the units column? That represents 5. So to add 10, we bring that 5 bead down and then add 5 more beads from below the separation bar.
So now we have 15 represented in the units column. The original 2 plus the borrowed 10. Now we can subtract 9.
Exactly. We remove 9 beads from the units column, which leaves us with 6. So looking at the abacus, we have 1 bead in the tens column and 6 beads in the units column. Our answer, 13.
Wow, that's pretty slick. It might seem a bit convoluted at first, but I can see how with practice it would become second nature. The abacus really makes borrowing a visual and understandable process.
It does, and the book emphasizes that practice is key. It suggests exercises like consecutively adding and then subtracting the numbers 1 through 9. This helps solidify your understanding of both operations and how they relate to each other.
It's like you're building a mental model of how numbers work, not just memorizing facts.
Yeah.
I'm really starting to appreciate the depth of the abacus. It's so much more than just a calculating device.
You've hit the nail on the head. It's a tool that fosters mathematical thinking, number sense, and problem-solving skills.
This has been a fantastic deep dive into the world of the abacus. I feel like I've unlocked a whole new way of understanding numbers and calculations. And I bet our listeners are feeling the same way.
I hope so. The abacus might seem like a relic of the past, but it's a timeless tool that continues to offer, valuable insights and learning opportunities.
Absolutely. It's a reminder that sometimes the simplest tools are the most powerful. And who knows, maybe this deep dive will inspire some of our listeners to, dust off an old abacus or even try building one themselves.
That would be fantastic. And if anyone's looking for a guide, the Abacus Made Easy is a wonderful resource. It's filled with, clear explanations, helpful illustrations, and practical exercises.
It's been a pleasure exploring this fascinating tool with you. And to our listeners, thank you for joining us on this mathematical adventure. We hope you've gained a newfound appreciation for the power and the elegance of the abacus. Until next time, happy calculating.